So look at it, worksheet 4. In fact, there's the notes to myself. Odds together. That means, well, let's just work the odd ones together. Because we know how to do double angle formulas. Some of these are worded a little bit differently. So we'll do every other one and make sure we're okay. We should probably start with a reminder. Sine of 2x equals 2 sine of x cosine x. You have this written down, but I'm going to write it down again because writing it helps me learn it, even though you don't have to have it memorized. And writing it means I won't have to think about it later because I can just look at it and it's right there. Cosine of 2x is cosine squared x minus sine squared x. And tangent of 2x is 2 tangent x over 1 minus tangent squared x. Again, we already know those, but rather than have to flip around and find them, just have them right there in front of us. The only thing that we're going to kind of add today is to kind of mess with cosine of 2x a little bit, which is what was going on in number 6 and number 7. If we replace, let's see, sine squared plus cosine squared equals 1. We already did one of these. If we replace cosine squared with 1 minus sine squared, then we get 1 minus 2 sine squared of x. If we replace sine squared is 1 minus cosine squared, then we end up with, let's see, that'd be cosine squared minus 1 plus cosine squared. So you end up with 2 cosine squared x minus 1. So we need to sort of readjust our thinking on the cosine double angle formula. I mean, if it's just up to you, you're probably just going to use this one and be fine. But we're gonna write some problems and rig some problems that sort of force you into knowing these two as well. So the only new thing today are these other two statements of cosine of 2x. All right, let's do number 1. Let's just see how far we get. If sine of x equals 1/4 and x is in quadrant 1, then find the exact values for all of these without solving for x. So this is a picture problem. Quadrant 1, we like quadrant 1, everybody's positive. Opposite over hypotenuse. Finish the triangle, apply the formula. I'm going to pause the video and let you try it. Here's the solution to number 1. Again, we've done problems like that. That should be old news for us. That's almost a warm-up type question. Draw the picture, apply the formula, be careful with the math. So some of you have calculators out and some don't, and I did it without calculator. And you can have a calculator with you because some of them you can definitely use it and you'll have it for the test. It's just if you try to use only the calculator, you're going to get a weird answer for A and C. So you have to be careful. If a square root shows up, know that you can't really use the calculator. If the square wipes out the square root, then you're good to use the calculator and check. So you could have checked B, but you couldn't really check A and C. Questions on that one? All right, let's skip ahead to number 3. Again, we're going to just try to do every other one and see how far we get. Evaluate each expression without a calculator. So number 3, I don't know what the cosine of 22.5 is, but I do know that this looks like, so ignore the 22.5. Cosine squared minus sine squared, that sounds familiar. What's that equal? Cosine of 2x, where x is 22.5. So this is kind of using the formula backwards and realizing that This is the same thing as cosine of 2 times 22.5, which is the cosine of 45, which is root 2 over 2. This would be a good one that you could use the calculator on. So if you wanted to take the cosine of 22.5, you better be in degrees then, squared minus sine of 22.5 squared. So if you write 0.707, you're not going to get credit because I need to see the pre-cal stuff. But if you want to check that that's equal to root 2 over 2, these should be the same thing, and they are, so I can feel pretty good about my answer. So it's another one where the calculator helps check, but doesn't really help you arrive at the answer. All right, why don't you try number 5? So match up the formula, figure out what x is, and hope that it's a unit circle value. So this is the double angle for sine. And the sine of 225. It's in the middle, so it's root 2 over 2. But it's third quadrant, so sine is negative. And again, I'm not going to do the calculator on this one, but you could do the same thing in the calculator. Type it all in, type in your answer, see that they do in fact match. Number 7 is similar, but you're not really going to get an answer. You're just going to simplify the expression. So this looks a lot like, let's see, that's cosine squared minus sine squared. That's cosine of 2x. Although, it's kind of tricky if there's an x already in there, so I'm going to switch up my variables and just say that it's a u. Because now I can see that 9x is playing the role of u. So cosine of 2 times 9x, which is the cosine of 18x. But I don't know what x is, so I can't take that any farther. So that's what it means by simplify. So use your rules, clean it up, but you can't really go any further than that. That 9 kind of started in pencil because it looked a little tricky. So it definitely looks like sine u cosine u, or 2 sine u cosine u. Where u is equal to 8x. So that would be sine of 2 times 8x, which is sine of 16x. But there's like this 2 and this is 4, so something's not quite right. Like I think I need an extra 2 out there. So what's inside the parentheses, that's the formula, but there's still an extra 2 out there. So 2 sine 16x. That one's kind of tricky with that extra 2 floating around. Maybe it would have been easier to rewrite it, pull the 2 out front, and so then it does look like maybe that would be an easier way to write it first. Because we have a formula for this, and that extra 2 is just kind of going along for the ride. So that one's kind of tricky, and it happens again in number 10. All right, flip the page. Here's what I definitely wanted to get to. Some equations. We haven't done equations in a while, so this is going back a little bit. Solve for all solutions on the interval 0 to 2 pi. So that means I don't have to worry about plus 2 pi k. I just need the answers from 0 to 2 pi. All right, 6 sine 2t plus 6 sine t. Well, I can't combine those and say that that's 6 sine of 3t. It doesn't work that way. But I do have an expression for sine of 2t. The 6 is still out there. The sine of 2t is 2 sine t cosine t. You have to write small when we get all of these in. And that 6 is still out there, so that's 12 sine t cosine t plus 6 sine t equals 0. Okay, that looks a little better. At least that should look more familiar. We've solved ones like that. What should we do to solve that? Do you remember? They both have a sine t in them. So let's factor. There's going to be some factoring on this worksheet. So let's factor out as much as we can. So I'm going to factor out a 6 sine t. So in the blank, that would leave 2 cosine t plus 1. Is this looking familiar? One head nod. Yeah, kinda. Then we set each factor equal to 0. So 6 sine t equals 0. 2 cosine t plus 1 equals 0. Alright, so sine is equal to 0 when t is 0 or pi. Or 2 pi, but we didn't want to include 2 pi. So 0 to 2 pi, but don't include 2 pi. The other piece takes a little bit of work. Cosine of t equals negative 1/2. I usually need a little picture to see. So that would be at the over 3's. So 2 pi over 3 and 4 pi over 3. So most of number 11 was old news. The new part was replacing sine of 2t with 2 sine t cosine t. So using one of our identities to make a swap to make the thing work. Same issue. Cosine of 2 theta and cosine of theta. What's cosine of 2 theta equal? Oh, you know what? We're tight on space, so let's be smart about this. I have 3 options for cosine of 2 theta. Right? The first one was cosine squared minus sine squared, and the other 2, there were other options. But since this problem already has cosine in it, I'd rather keep it with cosines, not muddy it up with cosines and sines. So look back, what was the formula, or what's the equivalent for cosine 2 theta that only has cosine in it? So there's 3 options. They're all equally correct, but only one of them is actually helpful for this problem. So I'm looking back at my cosine double angle formulas, and I've got 1, 2, 3 choices. But if the rest of the problem that we're working on, number 13, only has cosines in it, I probably want to pick this one, because that's the one with cosines in it. Otherwise, I'm going to have to do another substitution. So 2 cosine squared theta minus 1 equals 6 cosine squared theta minus 4. And we're tight on space, so let's see if we can do a couple of algebra steps at once here. I'm going to add the 4 over, subtract 2 cosine squared over, divide by 4. So cosine squared equals 3/4. Oh, I like where this is going. This is going to work out for us. What do I need to do next? Square root it. And what do you have to remember when you put the square roots on? The plus or minus. Now it's easy to remember when I ask specifically, what do you have to remember? But will you remember it when you're flying solo on these? I hope so. So cosine equals positive or negative root 3 over 2. Let's see. Cosine is root 3 over 2 at the shallow angle. And because it's plus or minus, I got 4 answers. So basically all the shallow angle, all the over 6s. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, why don't you try number 15? So use a formula for sine of 2t. And then a hint will be, don't divide both sides by anything, but move stuff over and factor it out. So try 15, but don't be dividing anything. Move stuff over and factor it out after you make the substitution. So there's the answer to number 15. Apply the formula. Again, don't divide by cosine because you'll lose solution. Move the cosine over. And then it's just like, in fact, from this point on, we've done those types of problems before. So it's apply a new formula and then work it like an old type problem. 17 looks a little bit goofy because there's a 3x and a 6x. But instead of writing that as 6x, how could we rewrite that might make it fit our formula better? Thought you were on the right track there. Cosine of 2 times 3x. Because we have a formula for this. Oh, that's the one where we have 3 formulas for that. So I need to be careful about which one I pick. Right? The cosine of a double angle is either cosine squared minus sine squared, or it's one of the others. And since this problem has cosine in it, I probably want to use the one we used a few minutes ago, which is 2 cosine squared of the angle minus 1. But what's the angle that we're using for this one? It's not just x, it's the 3x. So 2 cosine squared 3x minus cosine of 3x minus 1 equals 0. That's now a factoring problem. Cosine 3x, cosine 3x. It's got to be 1 and 1. And then it's a matter of getting the pluses and the minuses in there correctly. Let's see, I want the cosine 3x to end up negative, so I'll put the minus across from the two of them. That way we end up negative. So this means cosine of 3x equals negative 1/2. Cosine of 3x equals 1. So that means 3x equals, let's see, where's cosine negative 1/2? It would be 2 pi over 3 and 4 pi over 3. But that's what 3x is. Then we got to divide by 3 to get x by itself. Although, maybe I want to do this one. Oh, that one's easier. 3x would just be 0. So, running out of room. X equals 2 pi over 9. X equals 4 pi over 9. And x equals 0. Let's do 19 and then I'll be done. Manipulate the left side to equal the right side. So, tells me which side to work with, so I guess I'll FOIL that out. Uh-oh, we're really getting glitchy up there. So on number 21, on number 19, FOIL the left. The video's still rolling and it looks fine on the computer, so you guys will have to adjust for a minute. FOIL that out. Hopefully you can FOIL in your head. Sine squared minus 2 sine cosine plus cosine squared. Oh, this is, I think, is a little easier now. Whoops, now you don't have it at all. What's sine squared plus cosine squared? 1. And so I think that does it for you. You grab the sine squared plus cosine squared is 1. Oh, not quite there yet. But 2 sine t cosine t is sine of 2t. Omit 23 and 24. Omit 23 and 24. We haven't used those yet, so you can throw those out. Alright, well, this is going to be interesting the rest of the day, but at least I got the video recorded.